Hi, my name is Lindsay Sweckard, and this is my project on tonic immobility in amphibians as a literature overview. To start, amphibians are able to avoid predation using many different techniques. Some common ones are camouflage, loud colors that alert the predator that the animal is toxic, such as the orange frog shown in Figure A, loud sounds that startle the predator, secretions that can be sticky, slippery, or smelly, aggressive behaviors such as charging, using escape maneuvers, and finally, amphibians use different postures such as tonic immobility. Tonic immobility is also known as thanatosis or death feigning. It is a survival response exhibited by several animal species in the face of a predator or a life threat, in which the animal assumes an often death-like pose. So if you look at figures B and C, figure B shows a normal position of a frog, in this case it's Rhinella crucifer, and then figure C shows the same frog in the tonic immobility position. You can see that during tonic immobility, the frog is on their back with very stiff limbs and it appears to be dead. In this project, I researched which amphibians exhibit TI, the various ways they exhibit TI, and the factors that affect how and why certain amphibian species exhibit this behavioral response. The purpose of this capstone was to review and compare a wide collection of scientific papers on tonic immobility in amphibians in order to create general conclusions, as well as a library of knowledge about what is currently known on tonic immobility in amphibians. This will provide a useful resource for current and future lab students and may eventually contribute to an article or database for others to use. In the process of this research project, I searched for scientific papers using Web of Science to create a collection of reputable sources on tonic immobility in amphibians, and I proceeded to look through the sources those papers had cited and then write summaries, make a large table of the data from each paper, and finally compare the findings at the end. In total, I found 7 toad and 48 frog species that exhibit tonic immobility. Toads and frogs make up the same amphibian order, which is Anura. In Anura, there were many variations I found in the tonic immobility posture. First example, the hind limbs could either be loose, as shown in frog D, or stiff, as shown in frog E. There were also variations in which side the frog was laying on. In most of the species I found, the amphibian would lay belly or ventral side up, as seen in the right image of Figure F. However, there were a few species in which the frog would lay back side up or dorsal side up, seen in the left image. As you can see, the species shown in Figure F, Dendrophryniscus brevipolicatus, were able to lay on their back or their belly during tonic immobility. There were also a few instances in which a frog species would elicit a second survival response at the same time as tonic immobility. Examples included tongue protrusion, as you can see in Figure G, an ammonia-like odor being released from the mouth in Figure F, or rubbing the legs together for a toxic or distasteful secretion as seen in Figure I. So overall, only toad and frog species out of all amphibian species were found to exhibit tonic immobility. This could be due to the fact that many amphibians, such as salamanders, have bright colors that signal predators they have toxins, and therefore those bright amphibians would not benefit from tonic immobility in the same way as the duller colored amphibians. Tonic immobility is a widely used response in the Anura order of amphibians, and a majority of species I found from the papers I've cited display tonic immobility with the ventral side up, stiff limbs, and no additional anti-predator defenses other than tonic immobility at that time. However, there are a few species of Anura that use multiple survival responses with TI, or that used atypical TI posturing, such as the dorsal side up, tongue protrusion, or the odors released as shown, in order to increase their chance of survival against the predator. That concludes my findings of this project. I would like to thank my mentor, Dr. Bethia King, for her guidance and feedback throughout this project. Thank you for listening.